Okay, so let's take a look again at hybridization. So the impetus for this idea of hybridization came from the fact that the p orbitals, the shape of the p orbitals, are at 90 degrees from each other. So I've drawn all three of them, px, py, and pz, and they're all at 90 degrees to each other, and so they cannot form the angles that have been experimentally determined, such as 109.5 degrees in tetrahedral shaped molecules, 120 in trigonal planar, etc. And so this idea of the p orbitals that being at 90 degrees really puts a issue into this idea of molecules forming bonds at not 90 degrees. And so hybridization is this idea that the s and the p and other orbitals, but specifically the IB wants you to know that the s and the p can combine to create a hybrid orbital. So an orbital that is formed of both the s and the p shape. And what you get when you mix the s and the p shape is actually a hybridized orbital. In this case, I've drawn the sp3 hybridized, and that can form that 109.5 degrees. And so what happens when we're hybridizing orbitals, we have the s and the p electrons, and because of energetics, we'll not go into it specifically, but just because of energetics, one of the electrons in the s orbital is promoted to the p sublevel. What we then end up getting is a merging of the s and p. So you'll notice that the energy level of that merged level is between the s and p. So it's between the energy levels of s and p. And so we get a mixed sp orbital. In this particular case, because it's made of one s and three p orbitals, we call this hybridization, an sp3 hybridized orbital. We actually take the average of the orbital equations. And again, there's three types of hybrids that you need to know so we can blend the s and p in different ways. If we're taking all of the p orbitals, blending them with an s, we get an sp3 hybridized. That results in four orbitals that are at 109.5 degrees, which gives us that tetrahedral shape. Some examples might be CH4, NH3, or H2O. All of these have sp3 hybridized orbitals. And again, if we were to draw a picture, we would get that classic tetrahedral shape. Taking a look at our second kind of orbital, this time instead of blending together all of the p's, let's just blend together two p's. So we get sp2, that gives us a 120 degree angle, also known as trigonal planar. An example of that would be BF3. Finally, if we only blend together our s and our p, we get an sp hybridized orbital that gives us an angle of 180, which gives us a linear geometry such as BH2.